All right, welcome to Master the Light-Dependent Stage, Thylakoids and Grana. Most students lose incredibly easy marks on this specific topic. But by the end of this explainer, you absolutely won't be one of them. Today, we're breaking down the exact strategy that separates the top band Biology 9700 candidates from everybody else. And we're using real examiner insights to do it. Let's get right into it. So, why exactly do top biology students lose easy marks on thylakoids and grana? Picture this. You study the light-dependent stage for hours. You memorize the entire structure of the thylakoids, and you know exactly how the grana's massive surface area maximizes light absorption by photosystems. You walk into the exam feeling totally confident, but then the results come back, and that top band mark you expected, it's just vanished. Why? Well, it's usually down to a tiny, silent mistake that costs students their grades before they even realize what hit them. Okay, let's dive into this. We went straight to the Cambridge Principal Examiner reports for Section 13.1, Thylakoids and Grana, and isolated the top 3 traps. First up, using the right terminology but in completely the wrong context. Second, a fatal lack of attention to units and terminology. And third, providing this beautifully memorized answer that, unfortunately, has absolutely nothing to do with the specific experimental context they actually asked about. I mean, the examiners are practically begging candidates to notice these errors. Which brings us to a kind of harsh reality. Superficial breath fails. Just relying on ordinary rote memorization totally fails. Because Cambridge's academic benchmarks, they don't just want to know if you can recite textbook facts about photosynthesis. No way. They demand logical, structured reasoning that you can apply to completely unfamiliar contexts. They really want to see connected, conceptual understanding. Analytical depth is what actually wins the marks here. Section 1, the method mark strategy. Now, what's really interesting about this is a very clear alert examiners are sending us. They literally state that even if your final answer is wrong, method marks can save you. That's a huge deal. This is the single biggest clue that should completely change how you approach every single complex problem. They are heavily awarding marks for the process itself, but, you have to know exactly how to show that process to actually get the credit. We'll get to exactly where the examiner clicks the check mark in a second, but first, let's look at the framework that makes earning these points automatic. To really lock down those method marks, you need a procedural framework. It goes like this. Step 1, identify the key elements of the context. Step 2, apply the relevant biological principles. Step 3, and honestly, this is the absolutely crucial one, execute your analysis with perfectly clear working. And finally, step 4, verify your results and present them properly. Listen, if you skip step 3, you are literally leaving free points on the table. A huge part of executing that analysis is practical data interpretation. For example, if you're comparing the mean rate of photophosphorylation between 2 different light intensities, you must state you'd use a t-test. Looking at categorical data, maybe like the presence or absence of a specific photosynthetic pigment, that's chi-squared. And for relationships between variables, you go with correlation tests. Simply writing down the correct choice directly on your exam paper as part of your clear working is a prime example of securing an insanely easy method mark. Section 2, spot the error. Flawed versus improved answers. And this brilliantly illustrates exactly what we've been talking about. Look at the difference here. A flawed answer simply lists textbook facts, like just stating that grana contained chlorophyll. Sure, it's accurate biology, but it completely ignores the experimental data given in the prompt. An improved answer, on the other hand, connects that conceptual understanding directly to the context. It goes way further, questioning assumptions and justifying exactly how a specific change in, say, light wavelength actually impacted the thylakoid membrane in that exact experiment. The difference in marks here is just staggering. Okay, I want you to pause and predict for a second. Put yourself in the examiner's shoes. Looking at that improved contextualized answer, where exactly do you award the method mark? Think about it. It's actually not at the very end. The mark is awarded the exact moment the candidate explicitly references a specific piece of data from the experiment to justify their claim about the grana. The clear working is the justification. Boom, that's your method mark. Section 3, the evaluative thinking challenge. The syllabus actually demands a lot more than just clear working. It requires higher order thinking. Top-scoring candidates don't just guess their way through complex, unfamiliar contexts. Instead, they rely on this deconstruct, solve, evaluate pipeline. When you're hit with a brutal question on the light-dependent stage, first you deconstruct the given information. Then break it down into logical steps. Solve it systematically. Check your answer for reasonableness, like does this biological outcome regarding ATP synthesis actually make real-world sense? And finally, make justified recommendations. This pipeline is your absolute safety net when the exam throws a curveball. So the crucial point is really how you handle comparison within that pipeline. When the examiner asks you to evaluate alternatives or compare approaches in practical work, this checklist is your golden ticket. You must identify similarities and differences. You have to use comparative connectives, words like whereas or in contrast. Every single comparison needs solid evidence, and you absolutely must draw a conclusion about their relative importance. If you only list the differences, you've literally missed half the marks right out of the gate. All right, let's rapidly cement this mistake to mastery journey. Here are your 3 non-negotiable takeaways from this explainer. Number 1, always contextualize your terminology. Generic textbook answers about thylakoids will fail. Number 2, method marks matter immensely, so you have to show every step of your analytical working. And number 3, when faced with the unfamiliar, fall back on that deconstruct, solve, evaluate pipeline. So you've mastered the method and you have the framework to handle the biology. But there's a catch. What hidden trap in the exam's actual command words is silently putting a ceiling on your mark band right now? If you don't know the distinct difference between describe, explain, and evaluate exactly as Cambridge defines them, even your perfect biological method won't save you. Subscribe to Ace the Exam's IGCSE to excel in your Cambridge examinations and join us in the next explainer where we are going to crack the code on command words. See you there.